All right, my math friends, we've got lesson 3.2.5, applying the tangent ratio. So remember, we are now, instead of talking about the slopes of the angles, we've now named it tangent. And tangent, we found out on the last one, the slope angle kind of goes with the tangent because it's kind of like the change in y over the change in x. But now we don't have to spin our triangles in a certain direction. We're just going to do that the tangent ratio is always equal to the opposite side or the opposite leg divided by the adjacent leg. And adjacent, remember, means that's the leg that touches the angle. So as you're doing these and kind of, doing tangent kind of for the first time or you just learned it recently, it's nice to, when you do these, to actually label everything to make sure that you're actually doing the opposite and adjacent. It's good practice. So the 14 is our opposite leg. The x is our adjacent leg. This side over here we're not using. This is, again, our hypotenuse. So tangent of 54 degrees. Remember, that is a ratio, kind of like a slope triangle that we're doing, or the slope ratio that we're doing. Every 54-degree angle has the same ratio. And instead of calling it the change in y over the change in x, now we're starting to call it opposite over adjacent, 14 over x. Okay, so when we have x in the denominator, we talked about this last time, we can exchange the extremes. So we would just do x equals 14 over tangent 54. So on our calculator, we literally type that in. 14 divided by, I got the hiccups, tangent 54. Comes out to 10.17159,539, so on and so forth. We usually round this to like the nearest tenth or so. So I'm going to call that 10.2. That looks good. Now remember what you could have done instead to solve this, if you really like how we were doing it before with those ratios, we can just find out that the tangent of 54 is 1.376381922. And what you could have done instead, if this freaks you out with the exchanging the extremes, you could just do that 1.37638 whatever over 1. So that's the tangent of 54. And that's equal to 14 over x. And then you could have just done cross products at this point and solved it like that. This, we're rounding here, so this is more of an exact answer. If you round earlier in the problem, you'll be a little bit farther off from the answer. So this is not the suggested method, but at first, if you're having trouble with exchanging the extremes or knowing when to exchange them or when you're supposed to multiply, you can kind of fall back to old stuff that we've done before and try it out like that. All right, next few. So we go up to them, opposite, adjacent. 46 is my angle of reference there, so the tangent of 46 degrees is going to be equal to the opposite of x over the adjacent of 11. Okay, so for this one, to get x by itself, notice that the x on this one is in the numerator. The x on this one was in the denominator. So when it's in the numerator, we multiply everything by 11. And we get x equals 11 times the tangent of 46. Okay, plugging that into my calculator. 11 tangent 46. 11.39, let's just call it 11.4. So x is approximately 11.4. Next one, for this one, the opposite leg is over here. Adjacent, remember adjacent means it's touching. So the adjacent leg is the 11. Man. So tangent of 33 is equal to opposite over adjacent. So here's another one where we can multiply both sides by 11 because the x is in the numerator. So x is going to be equal to 11 times the tangent of 33. So approximately, let's see, 11 tangent 33, let's call it 7.1. All right, last one. So for the angle of reference of 36 over here, this one ends up being the opposite. And the x is the side that's touching, or the leg that's touching that angle. So that's the adjacent. So tangent of 36 is equal to 13 opposite over x, the adjacent. Okay, so this one is similar to the first one, where the x is in the denominator, so we can exchange the extremes on that one. So we can do x equals, or is it exchanging the means? I can't remember. Anyways, x equals 13 over tangent 36. All right, so we'll plug that into our calculator, and it's going to be approximately 13 divided by tangent 36, 17.9. Rounded to 17.9. All right, last one. We've got a little bit of a word problem here. Lindy gets nosebleeds whenever she's more than 300 feet above the ground. That's problematic. What if she goes to like Denver that's like a mile high? Was she going to get a nosebleed just all the time? It's got a gusher? I don't know. During a class field trip, her teacher asks if she wants to climb to the top of the Statue of Liberty. Since she does not want to get a nosebleed, understandable, she decides to take some measurements to figure out the height of the torch of the statue. She finds a spot directly under the torch that measures 42 feet away and determines the angle is 82 degrees. Her eyes are 5 feet above the ground. Should she climb to the top? Okay, so let's make a little drawing right here. So here we've got the ground. We're assuming Lindy is going to be on the ground. So here she is on the ground. Nosebleed dripping all over in a puddle on the ground. All right, so there's Lindy. She's a bleeder. So she is got a problem. Now she is 5 feet off the ground from here to here. That's 5 feet. She's looking up here. And it says up there, we've got a 82 degree angle. All right, so we've got a right triangle right here because it says she's directly above, or she measured from directly over here. So here's our right triangle. So she wants to find out, oh, and this was from here to here. That distance was 42 feet away. All right, so we want to find out our height here of x. So now we've got 82 degree angle of reference. We're going to assume that she was perpendicular right here. The opposite of is x, and the adjacent leg down here is 42. So we're going to say the tangent of 82 degrees is equal to x over 42. All right, so I'm going to multiply both sides by 42 to get x isolated. And I end up with x is going to be equal to 42 times the tangent of 82. Let's see what we get on that. All right, 42 times tangent 82. 298.84. Let's just call it 299. So x is approximately 299 feet. At first glance, this looks like she's going to pull it off. As long as she doesn't get up on her tippy toes and get up to 300 feet, her nose is not going to bleed. But we forgot something. Her eye level is already 5 feet off the ground. So the actual height of the Statue of Liberty here is going to be x plus this 5 over here. So the height of the Statue of Liberty is actually x plus 5. So, poor girl, she's got 299 plus 5 more feet. It looks like she's going to go to 304 feet. So as she gets past the few final stairs up there, she just gets a nosebleed all of a sudden. So she probably shouldn't go up there. It's right at her bleeding limit or whatever. So probably not a good idea for her to climb the Statue of Liberty, unless she's got a lot of Kleenex to stuff in her nose. All right, there we go. She should not climb if she doesn't want to get a nosebleed. She's going to be 4 feet over. All right, that's all we got. Short one. Math hard. See you guys later. Bye.